All right, in chapter 4, we're learning trigonometry. Recall that one of the areas is about right triangles. So we might want to ask a question like, how tall is this tree if we are standing maybe 5 feet away from the base, looking up at an angle of elevation of 20 degrees? So we're able to use the relationship of a right triangle to figure out the length or the height of the tree. So that's one type of trig that we're going to see. The second type is in terms of functions. So something like with an input and an output, like y equals sine of x type of a thing. So this is useful when we're describing things. For example, let's say we have, like in the ocean, we have tides. So maybe we have like a high tide or a low tide type of a thing, and we want to be able to describe what's happening, at what time do we have, the high tide, what time do we have low tide, how often does it happen, that type of a thing. So functions can be useful in describing various phenomenon, including these types of things here. So that is what chapter 4 is about. In this section specifically, we want to be able to do these 4 things. So determine which quadrant an angle lies in, finding coterminal angles, converting angles from degrees to radians and radians to degrees, and finding complement and supplement of an angle. So unlike in Algebra 2 trig, in pre-calc we are mostly focused on radian angle measures. Okay, let's talk about standard position. Standard position of an angle measure is when you have the vertex at the origin, so right here, and the initial side lies on the positive x-axis. So you have your initial side on the positive x-axis, and then you have your terminal side ending somewhere so that you have an angle measure. So 2 different ways that you can have your angle. So let's say your initial side is always here because we're in standard position. If you rotate counterclockwise, the angle that you've created is going to be positive in value. So it's positive if you go counterclockwise. So that means if we rotate clockwise, right, that is going to be the negative direction. So here's my initial side, and if I were to rotate my angle clockwise, that angle measure would be negative in value. So the positive, negative just tells you which direction you're rotating. One way to remember this is to think about quadrants. So quadrants. Okay, so remember quadrants, it's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So when we're increasing, when we're going up 1, 2, 3, and 4, right, that's the positive rotation. So you can think of that counterclockwise, right? This way, counting up 1 is going to be the positive direction, or rotating in the positive direction. So in degree measure, some important points that you want to remember, or important angles that we want to remember is here's standard position, right? So here's 0 degrees, then we go up to 90 degrees if we're rotating. This is 180 degrees, and do you remember which this last one is going to be? It's 270 degrees. And then again, we go to 360, and we would keep adding by 90. Again, this is if we're rotating in the positive direction. If we were to go the other way, again, standard position, you always start right here. You're still at 0 degrees, but if we go this way, you're now at negative 90 degrees, then you're at negative 180 degrees, and then you are at negative 270 degrees, negative 360 degrees, and you could keep going. Now, if you think about degree measure, what you're doing is you're having a full rotation, and you're calling that to be 360 degrees. And then you divide it into even pieces, 360 to be exact, and you're calling one of them as 1 degree. Okay, well, we have radian angle measures, and that's defined in a different way. So again, we still have a full rotation, but what you do is whatever this radius length is, you go the same distance in your circumference. So you have an arc length of radius r. And that angle that's created between, that is considered to be 1 radian. So let's say if we have a circle and we have a radius of 5 centimeters. If we travel 5 centimeters along the circle, right here, and I stop, that angle that's created in between, that is 1 radian. One important thing you want to remember is that 180 degrees, so in degrees, right, that's equal to, do you remember how many radians? Good job. Pi radians, right? Pi radians, that's the conversion factor. 180 degrees is equal to 1 pi radians. So you'll see this as just pi rads, or usually it'll just say pi. It's implied that it's in radians because you do not see that degree symbol here. So let's take a look at this example here. It says determine the quadrant, right? So quadrant 1, 2, 3, or 4 in which each angle lies. And the angle measure is given in radians. So let's take a look at this first one here. You have 5 pi over 6. So some students like to convert this into degrees and then place that. And that's perfectly fine, but this is how I like to do it. And I find it, a lot of students find this way like more intuitive. So hopefully that'll be easier and more efficient. So what I do is the following. I know that pi is 180 degrees, right? So I'm cutting that pi, right, 180 degrees, into 6 slices. So I imagine that I am cutting it into 6 even slices here. All right, so that would be like 1/6 of a pi, 2/6 of a pi, 3/6 of a pi, and so forth. But I want to be at 5/6. Okay, so 4 pi over 6, that's 5 pi over 6. Pi is equal to 6 pi over 6 because it reduces down to just 1 pi. So I know that 5 pi over 6 lies right here, and that is going to be quadrant 2. Okay, again, this way of thinking is going to be really helpful when we do more things like finding coterminal angles, complementary and supplementary angles, as well as when we do the whole unit circle. Okay, again, I recommend that you think in terms of slices of the pie, right? Like in terms of fractions. But if you prefer, you could also think, remember, pi is 180 degrees. So you really have 180, so 5, right? I'm replacing pi with 180 degrees divided by 6. And you can reduce that. So 6 goes into 180 30 times. So 5 times 30 degrees, 150 degrees. And we know that 150 degrees is in quadrant 2, right? Because that's 90, that's 180. And so we could also say that our angle lies in quadrant 2. Now let's take a look at example B. It says negative 5 pi over 3. Okay, again, 2 ways that you can do this. I know that it's negative angular rotation, so we need to be going in the clockwise direction, right? So we need to be rotating this way. So again, there's different ways you can do it, but I know that if I have negative 1 pi, right, so negative pi would be here, I'm cutting into thirds. So if I cut into thirds, right, that would be negative 1/3, that's 2/3, that's 3/3, and I have to keep going. That's 4/3, and that's 5/3. So negative 5 pi over 3 would be right here, right, all of that, which would give me quadrant 1 as my answer. So at a certain point, you get really comfortable with it and you can start visualizing it without having to actually draw out these little slices. Again, the other way you can do this is pi is 180 degrees. So I think 180 divided by 3, 180 degrees divided by 3, right? That's 60 degrees. So I do negative 5 times 60 degrees, giving me negative 300 degrees. And then again, you have to place that, so that's standard position. We're going the negative angular rotation, so we have to go clockwise. We're going negative 90, 180, 270, negative 300 would place us in quadrant 1. So those are two ways you can figure out which quadrant an angle lies in. Okay, now let's talk about converting angle measures. Converting angle measures. So we kind of already talked about how you can convert from radian to degree. So again, an example might be convert 5 pi over 3 radian into degrees. Again, I would say the easiest way is just to replace that pi with its equivalent, which is 180 degrees. So that's like replacing 1 kilogram with 1,000 grams because they're an equivalent unit conversion. So I know that since 1 pi radian is equal to 180 degrees, you can swap them. And then you just reduce, getting 300 degrees in this case. Okay. Just as a heads up, sometimes you may not get a nice integer like this, and you may need to leave your final answer as a decimal or a simplified fraction. Okay, let's take a look at converting from degree to radian now. When converting from degree to radian, let's take a look at an example. If I give you 110 degrees and I want you to convert this to radian measure. So what I would do is 110 degrees, I'm going to multiply it by a unit conversion factor. I know that 180 degrees is equivalent to pi radians. Do you guys see that? Again, this is a form of 1, right? Because they're equivalent, right? 1 pi radian is the same thing as 180 degrees. When I reduce this, right, the degrees are going to cancel out, leaving me with that radians. Again, that can be invisible or you can write it out. I have 110, if I multiply straight across, 110 pi over 180. Cancel out the zeros, and I get 11 pi over 18 radians. Again, that radians is going to be implied, so you could write it as 11 pi over 18 as your final answer, or write it including the unit here. Okay, let's try an example. How many radians is 270 degrees? The correct answer is A, 3 pi over 2 radians. Two ways you can do this. 270 degrees, right? You want to cancel out the degree symbols. You're going to have that 180 down here, which is equal to pi radians. When you multiply straight across, you can reduce, and you end up with 3 pi over 2 radians. Okay, so that's one way you can do it. Another way to do this is to think about 270 degrees, right? 270 degrees positive would be right here. Well, this is pi right here, and so if I cut pi into halves, that's going to be half of pi, so pi over 2, so that's 1/2 pi, that's 2 halves, and that would be 3 halves, so that's 3 pi over 2. So if you can visualize 270 degrees and see that that's going to be 3 halves of pi, that would be an easy way to get the answer in this case. Okay, now try this problem. How many degrees is 11 pi over 4 radians? Fill in the blank. Alright, so 11 pi over 4 radians. Again, I know that pi is really just 180 degrees. So I am going to simplify this out, reduce. So I end up with 11 times 45 degrees. So 45 times 11, 45, 45, I end up with 495 degrees as my final answer. So in the blank, you should have put 495. Next thing we're doing is finding coterminal angles. Coterminal angles. So coterminal angles are angles whose terminal sides coincide. So they have the same terminal side. So for example, let's say I have on my XY axis, I have standard position right here, initial side, and let's say I have an angle that looks like so. Okay, so my terminal side is there. Let's pretend that was like 30 degrees. Okay, So this angle that you see here, that could be 30 degrees, right? If I have this terminal side here. But do you see how it could actually be like 30 and then going 360? So that 390 degrees, right? So 30, and then if you go another full rotation, that would end up at the same spot, right? So that would be 360. I could keep adding. I could go another 360, right? Do you see how I can start here? I can go 30 and then go 360 and then go another 360 again, end up at the same spot. I can go an infinite number of more rotations or revolutions and end up at the same terminal side. They all coincide. I could even go in the negative direction, right? Notice I can know that I also need to, whoops, coterminal angle because my final answer is positive, right? So it's positive 380 degrees. And the reason I might want to do that is because I also need to find a negative coterminal angle. So to get a final answer that is negative in its value, I'm going to have to take 380, right, and subtract another 360. Right, remember coterminal angles, you're adding or subtracting multiples of 360. You're taking away rotations. So from 740, I take away a rotation and I'm taking another rotation away, ending up with 20 degrees. Okay, but that's still a positive answer and I need to get a negative, so I'm going to subtract from 20, 360 again. So that would give me negative 340 degrees. So for your final answer, I say find a positive and a negative coterminal angle. You just need to give me one positive. It could have been 380, it could have been 20, or it could have been 740 plus 360, right? There's an infinite number of possibilities. You just need to be able to give me one correct one. And then you have to give me one correct negative coterminal angle. So your final answer needs to be one positive and one negative. So notice that from the beginning, right, you could have done, like you're like, oh, if I subtract, 720, because that's 2 times 360, I'm still going to get a positive answer. So maybe I'll do 360 times 3. Like you could have done it that way if you want to, right, and get your answer. Or maybe you're like, okay, well, 740 minus 720 is an easy one to do. And then subtract from that 20 degrees, the 360. Okay, so those are just some tips on how you might want to do this. Second example, let's say I have 13 pi over 6. Okay, so I have 13 pi over 6 radian. Again, I need to find a coterminal angle. That's one that's positive and one that's negative. So again, I want to remind you what we're doing. So 13 pi over 6, so 6 pi over 6 would be here, 12 pi over 6 would be here, 13 pi over 6 would be somewhere right here, right? And we're looking for coterminal angles. So angles such that if I were to draw them, it would like end up like looking the same, right? They're going to end up here. So 13 pi over 6. I'm going to take away a full rotation. So if I take away a full rotation, that's 2 pi. But I need to get a common denominator. So that's going to be 12 pi over 6, because 12 pi over 6 is 2 pi, which gives me pi over 6. So here's a positive answer. Again, you could have added a full rotation. You could have added 2 pi, which is 12 pi over 6 when you have a common denominator, getting 25 pi over 6 as a positive coterminal angle as well. But in this case, again, I would have had to subtract a rotation anyway because I need to get a final answer that's negative. So pi over 6, I'm going to take away another rotation. But again, remember, my common denominator is still negative 12 pi over 6. So my answer, negative 11 pi over 6, would be the easiest negative coterminal angle answer to get. So my solution could be negative 11 pi over 6 for my negative coterminal angle, and then one of these guys for my positive coterminal angle. Again, let's check that. Negative 11 pi over 6. All right, negative 11 pi over 6. That's negative 6 pi over 6. And then instead of being at negative 12 pi over 6 or negative 12/6, you're stopping one slice short, right? So we know that it is indeed at the same location. Look at pi over 6, right? That's 1/6 of a pi. It's in quadrant 1, right? So it's at the same spot. So we know that, you can check it that way as well. We know that these two angles are indeed coterminal angles to 13 pi over 6. Okay, let's have you do what you try. Find a positive and negative coterminal angle to the following. Negative 2 pi over 15. So if you have negative 2 pi over 15 radians, right, find a positive and negative coterminal angle. By the way, in your answer, when you're typing it in, right, type it in as like pi for your pi, okay? So for your positive coterminal angle, there's an infinite number of possible correct answers, but this is the simplest answer that you probably could have gotten. It's negative 2 pi over 15. You're going to add a rotation. So you're going to add a full rotation. But notice that when I add this, when I add fractions, I need to get a common denominator. So I get 30 pi over 15. Which gives me 28 pi over 15. So that would be a positive, positive angle, positive coterminal angle. So you would have written as 28 pi over 15. And then for a negative coterminal angle, we just need to take away a full rotation in the negative direction. So negative minus 30 pi over 15. So that would give us negative 32 pi over 15, or negative 32 pi over 15. Last part, yay! We are going to find complement and supplements of angles. So here's the question. If possible, because it may not be possible, find the complement and supplement of each angle. Okay, so two angles, so let's define some things. So complementary, if you think back to geometry, right? Two angles are complementary if they add up to how many degrees? 90 degrees, right? And they both have to be positive. So complementary angles are two positive angles whose sum is 90 degrees, or, right, pi over 2 radians. Supplementary angles are two positive angles whose sum is, do you guys remember supplementary, right, 180 degrees or pi radians. One way to remember this is alphabetically C comes before S, numerically 90 comes before 180. Let's take a look at an example. So given 148 degrees, find the complement and the supplement, or the complementary angle and the supplementary angle if possible. So remember, your answer has to be positive. So if I have 148 degrees, right, that's already more than 90 degrees, right? It's more than 90 degrees. So there's no complementary angle, right? Because it's already more than 90 degrees by itself. You can't have a negative answer because by definition it needs to be a positive angle, so it's none. So what about for supplementary? How much more do you have to go to get to 180? So you think in your head, right, 180 minus 148 degrees, and that would give us 32 degrees. So the supplementary angle to 148 degrees is 32 because when I add them together, I get 180 degrees. So when we do radians, it's the same thing, but it tends to throw students off a little more because it's not as intuitive. So if you have 2 pi over 5, okay, so complementary and supplementary. So 2 pi over 5, right? So that's that, and you're dividing to 5 slices. So 1, 2, 3, 4, 5. So 2 pi over 5, it doesn't look like it's halfway quite yet, right? So it's not quite 90 degrees, so it looks like we have an answer. So the way you find the complementary, remember the way we found the supplementary was like how, you subtract, you find the difference. So here we would do like 90 degree minus whatever angle we have. But since it's radians, we have to do 90 degrees in radian, which is pi over 2 minus the angle that we have. So pi over 2 minus 2 pi over 5. Again, we're dealing with fractions here, so we need to get a common denominator. We get 5 pi over 10 minus 4 pi over 10, leaving us with an answer of 1 pi over 10. So, right, it makes sense if I have 2 pi over 5, right, and if I add 10 over pi, that's going to give me pi over 2. It's going to be halfway of my pi radians. So supplementary, well, how much do you need, right? So for this one, I would just do it visually because I know I'm at 2 pi over 5, but I need to go all the way over here to 5 pi over 5. How many more slices do we need? 3 pi over 5, right? Because 2 pi over 5 plus 3 pi over 5 gives me 5 pi over 5, which is 1 pi. Or, right, if that doesn't make sense to you, or if you prefer, you can think, well, instead of doing 180 minus, we have to do 180 degrees in radian, which is pi. We do pi minus the angle that was given to us, which is 2 pi over 5. Get a common denominator, so you get 5 pi over 5 minus 2 pi over 5, and that gives us 3 pi over 5, the same answer. Again, you're asking yourself, how big is my slice to get to pi over 2? How big is my slice, or how many slices do I need to get to pi, or 5 pi over 5? Okay, so try this problem. If possible, find the complement and supplement of the angle. Now, notice that even though I don't have a unit, because I do not have that degree symbol here, I know that this is radian in angle measure, or in my unit. Okay, so if you don't see a degree symbol, then it's automatically radian angle measure. So if possible, find the complement and supplement of the angle. So 2 ways you can do this. One way is an intuitive way, and then another way is like an algebraic computational way. Let's think about 5 pi over 8. That's 5/8, right? So 5/8. So that's, and you can just kind of visualize it in your mind, right? 1, 2, See that 5/8, so that'd be 1/8, 2/8, 3/8, 4/8, 5/8. So do you see how you're already past that halfway point, that 90-degree point? So are we going to have a complementary angle? No, it's going to be none. Because 5/8 is already more than 4/8, which is halfway through. So it's none. The other way you could have done this is you do pi over 2, which is like 90 degrees, minus the angle that you have. Get common denominators. And notice you end up with a negative angle measure, and that is not okay because by definition, complementary and supplementary angles must be positive. So then you would say none. So same thing with supplementary. What would be the supplementary angle for 5 pi over 8? Well, I know to get to pi right here, that's 8/8, right? Or 8/8 of a pi. How many more slices do I need if I have 5/8? I need 3 more slices, so that's 3/8 of a pi, or 3 pi over 8. Again, the algebraic way of doing this would be pi, because that's 180 degrees, minus whatever angle you have. Get common denominator, get 8 pi over 8 minus 5 pi over 8, giving us the same answer of 3 pi over 8.